Okay.
There. Should be live. Oh, let me make this bigger here. So now that I'm on my regular computer,
Yay.
regular
For
computer, I have
once,
like
and probably for the last time for a while.
yeah for the last
Oh
couple weeks. It's
my
always
goodness.
frustrating to me to do these like our really cool stream with Andy coming up, but I'm gonna be on the road, and so I got to do it from the laptop. But it's okay. It works out. So um
Oh, that I just noticed our title for this, the flares of November,
yeah, I had to do
and the
Oh.
the
instead of the gales.
yeah. I
I
had to
figured
do
as
the
a
old
play on that.
Midwest, flair on things. Um, even though we have a lot of people that aren't from the area, but the ones that do watch will probably recognize it, because it was pretty much the day of, or the day after that.
Yeah. Day
So
after.
so it worked out. So we have a couple people watching, so we'll just roll right into it. So hi everybody, hi Margaret. Yeah, after our after our wonderful trip, we're doing okay now. It was kind of hard to sort of get over jet lag when you roll right into a major CME event that keeps you up again and again. So
Mm-hmm.
I
Like,
think
when
I,
is sleep actually going to happen?
oh my gosh. And then having to work, I worked this crazy event where it was basically from 9 a.m. to 2:30 a.m. So that was fun. So
Oof.
I finally got a little bit of sleep, so I'm doing okay now. And I fly to LA tomorrow. So, yay! Never ends.
Right back into it.
At least the severe space weather is over. Yay.
Yeah, so at least we got a break there. I mean, there's some. Well, we'll talk about it because we do have
Yep.
something going on. But from again from our friend a what is it 70 what are we 4772 is that the which numbers am I mixing up here for the AR region?
42. I've lost track of
I don't
sunspot
know. It's
numbers.
it's in the slide deck, so we'll talk about it. But anyway, so we had a lot of stuff happen last week. We ended our broadcast with before the big X5 flare, but basically put out there that they expect stuff that week. So it happened.
Mm-hmm.
So I'll let you guys drive if you want. You should have sharing privileges.
Well, I could probably drive.
Okay. But I'm sure most everybody watching probably saw something from
Maybe.
that event, as long as it wasn't cloud cover.
I've
Oh,
seen
Um,
to
great.
only be a few areas.
yeah. Is it not letting you?
Uh, I got kicked out of my own Google Drive.
Oh!
I got it.
It's okay. I'm almost there. There we go.
I had
Not
it
too
up at
bad.
least.
Yeah, I added in the jet lag still because it
Yeah,
took
that's
us
clever.
a
Yes,
while.
that's very true.
The sun has no chill. Oh yeah, there we go. 4274.
Hmm.
I
I
knew it
was
was
ahead of
4-2.
myself.
That's all I had.
And then Steve's in Flagstaff. So hey, hi. I know Arizona saw that too. At least,
Hmm.
well,
And California
and
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 California
Mexico.
and
Mexico.
Mexico. So anyway, so this is the update. Yeah, November 16th. So this is fresh. Our complex region is
4274 said bye-bye
yeah, said bye bye.
Hmm.
We have a
with another
With
negative.
minor flare, it looked like.
yep,
Yeah,
it definitely said bye bye with a flare.
it did. And then
Literally.
so we have a negative polarity coronal hole to contend with, which should be coming into play here soon.
I mean,
Um,
any really
yeah,
time
anytime
now.
now.
It probably is already.
Yeah,
That's
probably.
the sad truth
So
because it's fairly
It's hidden amongst
high.
current solar wind data.
Yeah, pretty much because it's fairly high latitude, so it's probably not going to amount to much as it passes. And the CIR, that initial compressed region, probably coincided with the CME arrival.
probably, yeah. But we'll get to that. So anyway, that's the latest update on the. So now we'll get to the flares in November. So I made this video here that has all four of them. The first one goes
Holy
really
FPS.
fast, but it's pretty cool to watch because
I
it's
mean, it
just
makes
like
sense. It has to go fast. This is over, what, five, 6
5 days.
days?
Yeah,
We'll
and
let it
then the
repeat a couple
parting one
times.
right there.
Yay.
So that was our fun of last week.
Yeah, what a region. Oof.
Yeah, it was angry. It was very angry. So it gave us
It's
some
been a
things
minute
to
since
work
I've
with.
seen one this angry and active on the Earth
It was
side.
May, really, right?
I mean, well, I wouldn't say Mays were anywhere near this potent. It was less frequent for sure,
Yeah,
but we had what, several different little CMEs mostly all hit at once. I'm
Hmm.
calling them little
yeah,
because
because these were all
they weren't
like
that big a deal
S-class
individually.
flares, so they were all pretty substantial.
Yeah, we didn't have SEP events anywhere near what we had with this one.
That
Yep.
is true. And we had the one from the five. No, actually, this last one. Yeah, the five was
No,
a
The
pretty good.
X5,
five, the
yeah.
five
Yeah,
was the
Yep.
first one when it
yeah,
was
it was pretty good.
barely in between the west limb and the center disk. Like that's the beginning of connectivity with protons, and so I'm pretty surprised we got up that high. I suppose we can do the CMEs now at
Yeah,
least.
there's the CMEs.
Stereo wave perspective,
Yeah, so
It's
this is.
easier to see.
which
Stereo A is in good position to actually see if it's Earth directed right now, so that's why I picked this.
Yeah,
And you could see that X5 is already more favorable for Stereo A. I did not include the X4 flare there, but they, as this region was rotating, it was seeing more the Stereo A was seeing more of a shock. So the last, I think the X flare, I have it further in the slide deck. It pretty much appeared as a full halo to Stereo A.
yeah, which makes sense. And what else is
which
cool about this
20
is
degrees west. What was the orientation of stereo wave back then? It was a decent
Mm,
amount.
I think it's
yeah, I think
yeah.
close to 50.
But what's cool here is you can also see how it had a north-ish bias too. So when it
Yeah, all three.
so
Mhm.
stereo A is useful for that. So well, here's the predictions and what actually happened. And I am gonna give them pretty good credit on this because they're pretty it's pretty much spot on.
At least the cut and dry cases where it's clearly obvious something's coming are a little easier to
Yeah,
forecast.
the first ones were forecast. It looks like they came in a little bit faster than what actually happened. But these are well within the margins of error. Like
Oh,
it's really
absolutely.
acceptable. For the X5, it looks like Swipsy won that one. that's
Yeah, I think
that's
so
pretty
too. They
close.
were the closest.
So
But all within a few hours. That's pretty impressive regardless.
yeah,
Hmm.
kudos to them on this one because it's a complex event. Speaking of complex, here we go. Here's the
Here's the solar wind analysis, the favorite part. All right, red, we've got some shock. So we have the initial shock first off, our regular solar wind. Everyone can see my mouse, right? I always forget if
Hmm.
my mouse is a part of this or not. Good. We have a regular solar wind. We had this a minor enhancement I noticed before that. What was that structure before we had the major hits?
That was actually a CME prior to this big event. We were
Yeah,
in a very tail end of it from one of the M flares, I think.
it was like minor enough that we I don't even remember batting an eye at it.
Hmm.
And then we have the shock, the initial shock up to 40 nanotesla, which I've only seen maybe 5 times total at most. And I'm going to, of course, bring up that it was the shock pushed up the solar wind so much that the structure of the solar wind as it's coming into Earth and ACE remain the same. So we have all these lines: yellow line BX, red line BZ, blue line BY. And all they did when this came in was increase in strength in the direction that they already were in, which is a sign of you have field lines that are apart. Well, now they're getting pushed further into each other, which increases the actual field strength over that region. So you have a shock from that, and then you have the actual front sheath of the CME hitting, which of course that's where we all know where all the magic started. And I would say almost immediately. I mean, from the sounds of it, it doesn't sound like it took more than an hour at most to really start kicking the earth, because we had early Aurora even for sunset or at least twilight time period. I didn't see anything till 9:30 myself, so I'm pretty disappointed. But anyway, point being, we had the sheath going through here, and then we finally had the flux rope kick in. Very large BX component. We knew this was more of a side glance. Unfortunately, most of it going to the northeast, I believe, is or at least northwest, to the north of us. So BX component took away a lot of the oomph in the BZ and BY direction. So we really didn't have much of a structured flux rope here. It, I mean, I did we decide what it was? Basically, a would have been
I don't.
I want to say a southeast north, but it doesn't even look like that really.
Yeah,
No,
it's
I don't
really hard to make
it's
heads
I
or
don't think we
tails
had
not
a
of.
coherent structure.
it's not identifiable because I think what might have happened with it, and again, it's just a hypothesis, it probably got sort of folded over or twisted around a little bit, and we were not going through it front. it's not a head-on collision, so to speak. We're going through the leg of it. So sometimes you don't really get to see much of a rotation. It's more of a kind of consistency. You don't see a transition from north to south or south to north or west to east. It's all like it's fairly flat because it's just going through same part of the structure. It's not crossing it, it's sort of glancing it. So it's clearly some sort of probably north to south field for possibly part of this, but
Who knows?
maybe east.
Like I think the eastern
NES,
field is definitely
possibly.
at least the consistent part. I don't know. BZ basically had no component. It's like we basically were in the YX plane almost. In this case, Z had very little to do with any of this.
Yeah, which unfortunately we all know when that happens, what happens to Aurora for us. So
Yep, it kind of
But
fizzles.
thankfully, we had
Yeah.
enough activity in this region here that it pushed it through most of the
It
night,
did.
and I think most people had Aurora, even though it wasn't the great stuff we saw from this angle here. And then we suddenly had a second structure appear, which we knew there were going to be two CMEs into each other. We had what, X1, X4?
Hmm.
Yeah.
I'm losing track of even the numbers. But we knew since CMEs don't cannibalize that they were going to be crunched together and we'd have a sandwich of them. So we had a second Fluxro pretty abruptly show up, which was good because it knocked the field strength back up as it started dwindling. However, as we see, BZ was positive the whole time, so we had some high latitude stuff happen, but nothing really occur after that. Solar wind speed was messed up. I was going to swear really hard in this case because it really deserves the faux bar. What is it? Fubar? There we go. But
Yeah.
we had a lot of high energy protons and generally, or even just high flux in general. And when that happens, the Faraday cups become very corrupted and they're unable to discern what's going where. So you end up with these erroneous readings that we have 400 to 200 or these jagged lines, kilometers per second. None of this is reliable. Speed stayed pretty close to 700 kilometers a second around that time period, though, from what I could tell. And then we had the next day, where we have our second faster X5 CME, X5, right?
Yeah.
Mhm.
Yep.
Coming in from the not even west limb. We're still well within center disk, just a little bit west of that at this point. And it had very little in its way, which in my experiences, as we found out, yes, it got here fast. I mean, we saw for the first time, no, actually, it's my second time seeing 1,000 kilometers a second hit, but we had about 1,000 kilometers a second, roughly 8 to 900 for the duration of that CME. But it had plenty of room to expand and to move through empty space, or we'll say at least the solar wind that wasn't there at this time, which meant it didn't really have to be strong. So we had a almost 40 nanotesla jump once the shock hit, and it very quickly decreased from there. It became very obvious, I think within the first maybe 2 hours, that we were not going to get much out of this and that it probably wasn't going to be worth much. I did get Aurora again this night from Central Ohio, as did I think most other people. It was not anywhere near as extravagant, but the reds were out again a little bit more. And then we had the flux rip structure show up on this one, which again,
It's another beat up looking.
Yeah, I mean, I would at first say it looks more like a east southwest, but I don't really know what to make of the BZ period here, where then things just swapped. It almost looks like two mushed together, but I'm assuming there's some shearing and twisting here.
Mhm.
And then that was pretty much it, though. We saw a steady decline on that note, and that was that. So our big night was Tuesday night, not Wednesday night, as we all assumed. Space
Fun.
weather always has a way of keeping you on your toes.
It does.
And then the DST.
Yep. So I threw these in here because
Yep.
I know there was some chatter about the DST on this because it was pretty significant. Minus 200, well, even a little past minus 200. So that puts it in the top running for, in terms of the storms.
I
that
believe
we
it's
had.
top 5 for this
Yeah.
solar cycle.
So it's nothing to sneeze at, that's for sure. Even though it seemed like it was only really great in certain parts of it, which is fine.
I'm sorry, wait, nothing to sneeze at?
Yeah, nothing to sneeze at. This was good.
Okay, sorry, that's the first time I've heard that.
Yeah. And you see the initial shock of it very, very clearly. It's
Yeah,
like the
love that.
initial uptick, that's the sudden
That
storm
huge uptick.
commencement.
Yeah.
And then it just dropped
And it
like a rock very,
dropped
very
like a
quickly.
wet balloon.
And then
like
you
a
see the
sneeze.
second, you see the second CME arrival there too.
Yep, and then we got this one
Yeah,
here.
not
And
quite
yep,
as
right there.
And
extravagant.
a very slow recovery time.
Yep,
As per
we
usual.
still haven't fully
Yeah,
recovered,
notice
but
we're not even back up there yet.
that's
Which
probably more a coronal hole and another
Mhm,
CME doing that. So yeah,
100%.
they're not amounting to much. So this
All right,
is yeah,
that's something else.
geomagnetic storming, and there was a discussion whether or not we actually reached G5, whether or not that was a
Yeah.
G5 storm. So the answer is no, we didn't. Because by convention, anything that is not exactly KP9 is not a G5. So KP9 minus under 9, so it's 8.66, is still counted as G4. And there was a debate again, HP30, which is slightly different index. It's calculated similar to KP, but on higher cadence. So we're talking about 30 minutes rather than 3 hours. Because it's calculated differently, it's not the same as KP. So just because you have HP30 of 9 or higher doesn't mean that it is the same as G5. So,
Nope.
but it reacts a little bit better to substorm. So you see more fluctuations and kind of more response to what solar wind was doing and what magnetosphere was doing in response to it. But still not quite enough to follow if you really want to chase Aurora. It's slightly better, but problem is it's also updated in real time. So the final HP30 for the interval that just ended, or as it's sort of calculating it, it's the number in progress. You don't know how high it's going to be. You don't know how high it's going to go. And it is often recalculated when it's finalized. So it's never a final version until it actually says final HP30, and that takes several days. Because not all the stations are reporting in real time, or at least not right away, not within that interval period. So if you're chasing based on HP30, I honestly don't know what you're chasing. You're chasing a number that is changing. It's and reflective of your geomagnetic activity at some point once it's finalized, but by that time it's too late. So yeah, not probably the greatest thing to change. And again, those values are not interchangeable. HP30 of 9 does not equal KP of 9.
Not even
Right.
close.
Nope.
And I know Justin asked like, why not just call it a KP 8 plus instead of 9? I'm like, well, that's a question for Space Weather Prediction
So
Center.
there is already a K plus. That's 8.33.
Okay.
Yep.
These are I really disagree with the way these are labeled and how they're done. It seems like they're just trying to make it seem better for lower values. I don't get it. I'm DST. That's
Well,
where
I
it's at.
think
Give me a hard number, the end, no disagreements.
I think
We're
they
done.
are looking into changing it. So
Yeah,
that's
God, I
definitely.
hope
where,
I mean,
so.
yeah.
HB30 is one of the contenders.
Hmm.
Problem is it's calculated in real time and
Yeah.
lags just because the stations are not reporting right away. So that may be problematic all by itself, although that might be easier to resolve than we think. So hopefully there is a higher cadence compared to what we have with KP, and hopefully the issue with station reporting and real time is resolved, but we we don't know that. We have KP now, and it's not useful at all.
Yeah.
But
So,
it's fun to watch. It's great for space weather climatology. So when you're describing a storm, you can say what KP changes have been seen and how active space weather was. It does not equal active aurora. And well, it's one of the ways to describe it.
yeah.
It's subaraural latitudes. The index was specifically designed not to pick up all the rapid shifts in currents in that are responsible for aurora. So KP is not designed to respond to aurora, therefore it doesn't track aurora very well by design. So we should not be using it.
Yeah, because it's what else?
We've only been saying that since day one.
Yeah. Well, like
Yeah,
the and then
that hasn't changed.
it's funny though too, because like I've heard people say that like this storm was better than the other ones, and I'm like, and yeah, like because again, like these indices don't track substorms, and they don't track like the real time things that's going on with the magnetosphere.
No.
So it's like,
Yeah.
so you'll get
They
sometimes these active periods that are just really quite dynamic.
I mean, Mary Beth, your post pretty much sums it up. The aurora's different every time.
It really is.
yeah.
It really is. And so,
Exactly. And this storm was very favorable for North America because we saw the
For
very
once.
beginning of it.
mm-hmm.
I know.
Yeah.
When October storm of last year hit, it actually was storming pretty heavily over when it was nighttime for Europe.
That's true.
So they
Yeah.
kind of saw the most of it, the most dynamic part of it. And we ended up seeing that beautiful sawtooth event where you just sit under a hazy sky. There's aurora over you, and it's not doing much until the next substorm comes along. This event was a little bit more dynamic. There was still sort of sawtoothy feel to it, but the substorms were more frequent because BZ was not stable. It wasn't stuck at
We
minus
got the break.
34
We didn't have
hours.
the SMC pattern. We didn't have
Yeah.
No,
the bull crap like waiting and then the small tiny substorms like a similar sawtooth pattern. No.
no.
So nice. Chaos.
Yeah. And that's exactly, but how quickly that polar cap expanded and how quickly Aurora moved from auroral latitudes to really mid latitudes, because I had it overhead and I'm at what, 53 geomagnetic, 53 north geomagnetic latitude, so 44 geographic latitude. It was over my head.
Yeah. And
And
we had it overhead at one point too.
it literally went from horizon to overhead, for horizon, just seeing the tips of that pink to overhead in an hour. I went through my photos and it's exactly an hour. So because it was so dynamic, because Aurora was actually doing stuff, yeah, it appeared as a better storm than October. It sort of visually was more appealing, but was it stronger than October? No. We just got to see the part of recovery from the DST perspective. The drop happened when Europe was in nighttime. It's
Timing.
a storm.
Yeah.
It's beautiful. We got Aurora out of it. I'm very happy. I'm not going to compare the storms. It's like, which one is better? All of them, and keep them coming.
Yes.
I love Aurora. The end. That's which one's better.
Yeah. So this is what Aurora was doing. And again, the moment that negative BZ is arriving, we pretty much get substorm. And it was very dynamic. So we saw some nice drops here, another drop here. And again, as BZ is starting to shift, you see a change in pattern. So there was a little bit of a holding pattern right there where it was not doing much. And once it loaded, it dropped again. And then it went for a break for a while. Wasn't as intense. And the speed was really not helping it. So speed was very high, and the substorms were pretty much responding to what BZ was doing. So you got some north BZ right over here. The speed is high. Is it helping your substorms? Nope. You still need something to charge the magnetosphere to substorm. And that's exactly what BZ was doing here. And once it moved into northern territory, speed was still elevated. Was Aurora doing things? No. But yeah, it was pretty impressive.
Overall.
Agreed. Oh yeah.
And that was a more recent event. So that's our X4, almost on the west limb, producing a beautiful halo for stereo A.
Keeping in mind, again, this is stereo A, although if we did look at Glasgow, there was a full halo component that was considered the shock, which was far outreaching the actual bulk of the CME. It was clear the bulk of the CME was not going towards us. So we really weren't expecting that much. But I've seen worse. September 2017, we had a West Limb CME that was extremely wide and powerful, and we got G4s out of it. And it was West Limb. So it's West Limb shocks aren't necessarily bad. This one was just not that great.
But we still got it.
And it was forecasted as a miss to a potential glancing blow, and we got it. And what was helpful for this one, at least from the IMF perspective, you can probably go to the next slide. That's the solar wind data.
Yep.
Yeah, this one. It probably combined with CIR from the coronal hole. So, you want to take this one?
Yeah, so we had our little minor shock. I think I sent out an alert like within the first 30 minutes or so. I saw it after it just hit over 10. I'm like, okay, guys, this is definitely the shock. I wasn't really expecting very much, and this is even less than I was expecting. So no, don't even worry about Aurora right now. Well, wait about 1, 2, 3 hours, and we finally did see some actual increase. So I'm like, okay, well, this looks like we could have something. It's at least up to 15. This could be mid-latitude stuff, except for that BZ hugged the VT line as closely as possible to the north. So we had absolutely absolutely nothing. As far as looking at, not that the KP indices matter, but I don't think we saw over a 3 for that entire period. We finally had some southern BZ, though, start kind of as BT came down and we started seeing the regular coronal hole patterns down this way, which would be the yellow then part is my assumption. I'd say that could be a flux rope, but I'll be honest,
Yeah.
there was no clear flux ropes here. None. So it's not like we actually know the orientations for anything. This is all just random at this point.
Yeah, no, I would say it's sort of a hint that there could be a flux rope, but this is not a flux rope. This is more fast solar wind doing things.
Mm-hmm.
And it's not particularly fast either.
Yeah, well,
we had what, 600? That's coronal hole speed. That's less than coronal hole speed. The last one we had was up to 700.
Yeah.
But this is a pretty northern coronal hole too.
True. We were not getting really hit hard on this one. It was kind of thin for our angle too.
Mm-hmm.
Oh, there we go. Now the SEP events, on the other hand, those are fun. I really don't get to see S2s or even S3s especially, but S2s even haven't been that common lately.
No.
So to see the fact, actually, does anyone else want to take this? I'll go over this one if you want to. But
yeah, go ahead.
Okay, fine. So we had our initial, this would have been the X5 sitting on in between the center disk and the west limb. Very hard spectrum increase. All energies of the spectrum were seen, including down here, which is 500 MeV, which I don't ever see this line increase. And I want to say it got up to 2. Oh, no. Oh, so this is kind of weird. These are supposed to be exponents, so that's not 100. That's actually 1. This is 10. So the point is, we saw up to 2 PFU, which is really high for 500, and honestly a little concerning, I would say, for the upper atmosphere at least. And then we had the arrival of the X1 CME, I want to say. Again, all these numbers are pretty hard to remember in my head. So we had, again, 10 MeV electrons knocked up to about 1,100-ish. I'm just kind of guesstimating based on this log scale here, which is really hard to read when it's so small. But the point is, it hit S3 very briefly and then very slowly decreased again until we get yet another CME arrival. I believe that was the X4 then, or the X5?
Probably.
I think that was X5, yeah.
Okay.
Oh, so X5 is, yeah.
We had, so let's see, what did we have above the 10 PFU for 10 MeV protons? We had almost straight up 72 hours of just elevated high energy protons in the atmosphere. That was always fun. And then we had that here, which I believe was the arrival of then the X5 that we saw, the shock. Which, not too bad. Yeah, we're finally almost back down to normal levels at this point. I really haven't seen much snow on LASGO imagery that we get when these levels get up to that way, so it's nice to see that again sometimes, even though it made the CME analysis harder.
Even though it's not doing good things to that imager.
No, and then of course we had plenty of bad things happen. GPS got significantly messed up.
That's the next slide. So that's not necessarily related to the solar energetic particle event, but it does. Storm. Yeah, it definitely blasted. So hold on.
There it is.
Well, hold on, but it blasted communication. So over the poles, there's essentially open area, and protons can go there freely. And that messes up communication, so transpolar flights were affected. And I think Sean Dahl, who was doing live briefings during the storm, said about 21 flights were canceled because of the storm. And it's bad for equipment, and it's bad for humans in orbit and actually on the planes. That increases the radiation exposure. So it's a good thing that flights were canceled.
A little bit in this case.
Yeah. So next one. Yeah, there we go.
Now we got the GPS.
So this is fun. This is GPS. So Mary Beth, you want to take this one? Or do you want me to take it?
Yeah, so this is the, I forget, wide angle, I forget the rest
augmentation.
of it. Augmented. So yeah, it's used in aviation, basically showing where the GPS signals are being, what is the term for that, scintillated? So that way they're either incorrect or off, or, they're just not, it's not working properly. And blue is where it's good. And as you can see, there was some pretty big degradation of GPS signal disruption, kind of right where the oval got kicked out.
Did we have the regular version of this? What it looks like before all of that? I don't think we put that up.
I don't know
I
if we did
don't
either,
think
but
I put it, but I can probably pull it up and share it. But
yeah.
Fair. It's
basically
See all
blue
that.
normally
everything,
all up here.
Yeah.
yeah.
So that's a lot of error. That's a lot of GPS error. So if you imagine if you're in an airplane and then your GPS signal's like, I don't know, miles off course, that's a
Well, actually,
problem.
it's not miles
So
off course. If you look at the
yeah.
bar to the right, it's giving you the error. So normally, it's accurate. It's not even 20 meters. It's accurate within very, very narrow range. It tells you where the aircraft is in vertical space. So if your margin of error now is 120 meters, and this system allows you to land it by pretty much hovering over the landing strip, 200 feet or so. But if your area is now 120 meters, landing based
I
on
mean, that's like
that system
sideways.
is impossible.
Yeah, it's
You have to use other systems. And the thing
yeah.
is, it affects other things. It does affect navigation. So GPS can malfunction in those red areas. Your GPS not going to be accurate. It might be leading you into the field instead of a freeway. And if you're a drone operator, well, Mary Beth, I think you have a story.
Yeah, there's a
Not yours,
not
fortunately.
my story, but so Adrian told me this story last week when I was in Norway that he had a friend who brought a drone up there and he wanted to fly it with the Aurora going on, and he warned him, is like, hey, you know, these are a little bit older drones too, because they're supposed to be a little more robust now, but because I've flown mine in, but maybe not in a big geomagnetic storm, but anyway, that's neither here nor there. But so he took off, he was flying it, and then all of a sudden the drone just flew away, just by, never to be seen again, because the GPS wasn't working. So it didn't know where it
Lost
was.
$100,
Um,
$100+ drone.
so you have to be
Hundreds.
careful with this stuff. Anything that is reliant on GPS signals, because when you lose the accuracy, bad things can happen. Most aviators in the Arctic regions are well aware of this, and they don't rely on GPS usually.
Mhm.
They just know because they have nightly Aurora. You know, it's like so this is going to be a problem. That and they're being on the edges of the grid because these satellites are they're more in position for the middle latitudes anyway. So you get up into Alaska, and then the satellites actually only come up on the horizon a bit up. So your signal's already degraded up there because of the position of the satellites. So, yeah. Long story short, the people up in the Arctic regions are well aware of these problems.
Yeah, I can probably share the normal look. So the
Okay.
Yeah.
current look, nothing is disrupting it, so
Oh,
I can
before we
share
do,
that.
I do want to mention that
Yeah.
the most disrupted look, the region that's still okay, looks pretty similar to Australia.
Yeah.
Anyone else
It
see
kind of
Australia
does.
continent there? And moving on.
All right, so let me share this. So this is what it normally looks like.
Right.
So the precision is very high. So vertical protection layer, um, basically you have nice precision there, and nothing is really disrupting it or interrupting it. Everything is in the blue. So when you start to see red patches over Canada, continental United States, you know you have a problem. All right,
Yeah, that's a fun little chart.
back back to the slides.
Yeah.
I think we have a couple more
We
Yeah.
do.
that are fun. So
This is
this
a
is
fun one.
another one. Yeah, this is a fun one. Geomagnetically induced currents. Well, when there is a current flowing in ionosphere in upper layers of atmosphere, it's going to induce magnetic field on Earth. And if you have a long conductor, like a power line or a railroad, it's going to start developing currents in it. And it's a huge issue for power grid. And New Zealand really have been very transparent with what's going on with their space weather and how they have to mitigate. So they had to take one, two, three, four lines out and reconfigure the grid because they were taking the lines where there was sort of a direct current. So their system is operating, every system pretty much, power grids are operating on alternating current. It's going both ways, alternating in between. When there is a direct current, the power grid is really not designed to work like that. It is really disruptive. It starts to overheat transformers. So they had to take 4 lines out to keep power going. No disruptions were seen. Everything was successfully mitigated. Given how much of a disruption we've seen and where the auroral oval was over continental US, I can guarantee you that our power grid operators had to do similar procedures. They're just not talking about it, but they were doing it. So if you did not have any power disruption when Aurora was overhead for you, thank you, power grid operators, for doing their job, because that's exactly what they're supposed to do. It also affects railways and power lines. So for countries that do rely on rails extensively, they have to keep in mind that the signals can change. So if the track is green lighted and all of a sudden the light switches to red because of the current in it, it's less of a problem compared to a red light switching to green, which can happen.
Yep.
So they have to keep that in mind and be aware of it and start to rely on other procedures that train is actually on track, so they're avoiding collisions. So that's kind of fun.
Fun times.
And
And yes,
the physics
pipelines,
part of
they
it.
start, yeah, and the pipelines, because they're super long and they're typically made of conductive metal, they corrode a lot faster and can develop leaks. Not fun. Not great for environment.
For the physics part of it, as we know, a changing magnetic field induces an electric field. So we have our magnetic field of Earth being heavily vibrated from the CME. We create currents from that. Those are the geomagnetically induced currents, best in long conductive wiring, basically. So that's where we get all of this.
Yep.
Electromagnetics is fun. Next slide.
All right.
Yay, more fun stuff.
So now you can show the Aurora. So this was from Galena, Illinois. This is where I went with sand kelp, but I just put this time lapse together to show you the just how much the red really just took over the whole thing, and it like color casted everything. It was actually really hard to photograph because the reds were so intense that I actually had to underexpose this quite a bit and then bring it up in post, because otherwise you get these like the reds were just almost blown out.
Blotchy. Mm-hmm.
Yeah.
I noticed a few photos I have that are like that.
Yeah, so I had to like really bring the exposure down almost to where it was like too dark, but then it would save the highlights in the red. It's not a very common problem.
No.
So I figured I'd show that one.
Yeah.
But yeah, it was a proton aurora fest. You can see the proton aurora coming in and out here. It was clear to the south at one point, even where I'm at, which I think I'm at 42 degrees north. I forget what that is, geomagnetic latitude, but it's pretty low. I put these in here too because I think they're cool. The auroras across America, basically every state saw them. I know cloud cover was an issue in a lot of areas, but there were some pockets that were able to see them, even in Michigan. I think it was like the southwest corner.
Yeah.
But it's really neat when you get a storm where basically every state sees it, and you can see the amount of red that was everywhere. It was definitely one to remember with the red. And then the other image is the composite was showing the auroral oval from the satellite view, and you can see how it's been kicked down pretty far, like right over the northern U.S. line.
I wish it had the maximum extent.
Yeah,
right. It's not even the peak of the storm, because the satellite passes for North America happen. They usually happen early morning,
Yeah.
so they're
So it's
around like 3 a.m. or so.
And then
So they're not even seeing the full extent, because I know for a fact that I had it overhead,
yeah.
and that auroral oval does not even extend that far.
So yeah, and that's the problem with that, is like it only does passes every so often. Like we also know that it was kicked out of Norway, and it shows that it's over Norway. So, depending on where, when it's taking its picture, makes a difference. But still, it shows a pretty nice extended oval, which is pretty neat to see. That's all I got on that slide. I think that might be the last one.
I think that's the last slide.
Oh yeah,
Almost.
Wow.
So what kind of big take-home messages? We saw CME interactions, and forecasters do the best that they can to
Mm-hmm.
predict the storming level and warn the infrastructure that something big is coming. But the interactions are very difficult to model. So we ended up with greater storm from two CMEs that came close together as opposed to one X5 flare
Yep.
that was supposed to be the big deal, and it never really was a big
It
deal.
wasn't.
Yeah, and when you see the storming, Aurora is hot right now, so you're gonna see hype. Just try to ignore as much as you can because it's not gonna be as great as people say it. There is
I
always a
mean,
risk. I saw so many of my friends posting, "Oh, Wednesday night's gonna be even bigger than Tuesday."
yeah, like
No,
no.
we don't know.
They're still milking it. Some of these accounts are still saying like, "Oh, the Aurora is going to be tonight."
Each day
And yeah,
after has been, oh, it'll be great
it's
this
like,
day.
"Hold
It'll be
up."
great this day.
Yep, exactly. And
Chase
as
the data, not the
usual, yeah,
forecast. That's an overrated, or I'm sorry, an underrated sentence. I mean, honestly, I feel like that kind of encompasses all the values we have here. The
yep,
forecast never pans out. The data almost always will if you can interpret it.
yep. Could not agree more.
But yeah, basically, even from the beginning when we talked about this last week, whenever you get a complex event, it's hard. You just know something's coming. You prepare for that, and you just kind of hope that you'll get something in your favor, which we did. But like you said, it was the earlier version or the earlier part of it, not the later part. So, but I mean, the predictions were pretty close. The arrival times, and so like a lot of the stuff was pretty well forecasted. It's just the strength and what happens is the part that's the mystery, and you kind of have to like take it upon yourself to realize like or how much you can handle the disappointment if it ends up being an all northward field for the most part, and how long you're willing to stay out and wait, especially like when you see these events where the BZ's pretty not very stable, so like it might do something for you. Yeah, patience. like the slide says, chase the data, not the forecast. Just know the
Yep,
forecast tells you that we're expecting something. That's about it.
exactly. Yeah, something to arrive.
That's
And
it.
even
Yeah.
and even then, for CME forecasts, a third of them never make it here, and that's pretty normal. So there's already some disappointment built into the forecast because CME may never come.
Yeah,
Kernel holes always do,
that they
not the
do.
CMEs.
Trusty curl holes. Sometimes they
Mhm.
sometimes they're kind of a pain when they deflect things, but you know,
Yes,
but
that is very true.
for the most part we like them.
We do. We're probably going to see we're still in the surge. We're still
Mm-hmm.
in that period of sort of solar season of increased activity where the activity is coming down. We're seeing coronal holes, so this is clearly a descending phase pattern, but we are seeing more active regions emerge, and I think there was one
There was one
emerged
today.
today. So that would be something to review for you, Christian,
Yeah,
because it's
it showed
sitting
up
very
like
close to the center disk.
yeah, it showed up like in like 12 hours. Like there was a span of like 12 hours. There was nothing, and then there was something all of a sudden.
Yep.
Well, then I will pull it up real quick while someone else distracts everybody for like two
Yeah,
minutes.
sure. So
Yeah.
we are, again, this is a surge. So this is just 11 to 12 months cycle that we see increase activity and followed by decrease. There is a recent paper on it. It is forecasted for December of this year. So we have probably more active regions and potentially more CMEs to look forward to and get frustrated with forecasts or deflections because, again, we're seeing kernel holes right now, and they're very good at deflecting CMEs. You
Mm-hmm.
could end up with a perfectly spaced, perfectly placed CME with kernel hole next to it, and it's not flying you away. It's going somewhere else. But we are in active space weather season, and things are definitely more coming, but probably going to start winding down toward the end of 2027.
Oh,
So,
it's still a couple years.
so if you're planning a vacation to see Aurora, you might want to consider it for 27, late 27, 28, 29, when we're not going to have much going on for mid latitudes, and it's all going to be in Canada, Iceland, Alaska, Nordic countries, but not going to be here. And obviously New Zealand and Tasmania.
Yes. Can't forget them.
Absolutely. But
Okay.
we're gonna see less of it. So
Okay, you got
And it
it.
also tells you that if you see anything saying, "Oh, this is the last year to see good aurora," or "Next year is the only year you have to see good aurora," you know it's a hype account, and you probably don't need to be following it.
That's right. Okay, so we
All
got
right,
our.
let's see what this is. I have not checked any of this out yet. I'm gonna
It's gonna be a
put up
surprise
the
for you.
magnetogram too.
yeah.
Let's make sure we have at least
It's gonna.
some magnetic layout.
It's
There we
gonna come
go.
up and say hello.
And this is
Right
pretty.
Yeah,
there.
there
Oh,
we
See?
go.
Look at that.
oh,
Look at. It's
okay,
like.
got it.
It's
So here
like
we'll do
hi.
this.
Hi, I'm here. It was
It's
there.
still gonna. It's gonna take some time to like
Yeah.
load the whole thing because of course I demand high cadence,
Of course you do.
which means it takes forever.
It's like hello.
Oh God, no. Let's do 45. Well, I can't really do it when there's nothing loaded yet. I always forget that it still needs to load, so even though I have it up, it doesn't actually matter. So let's look at it as of now. How about
Yeah,
that?
look at that. Look
Yay.
at it.
Oh, I like that. Oh,
Yeah.
this is
It's
interesting.
not very happy looking.
Where are we at? I need a grid.
Southern Hemisphere.
That's negative, so okay, okay, fair. So that's like -5 latitude or so.
Pretty central.
So it is a regular looking sunspot. I guess depending on how this grows, this could be either these three cores can very easily just merge, in which case they will drift to the north and this won't be a very big deal. Or if this negative or positive umbra decides to develop more, we could see it in the center and kind of interact with this. So yes, it definitely could be something. What is it labeled? 4300 something,
I
I'm
think
guessing, or 4290 something?
4284.
4284? Okay.
Jesse put it in the chat.
Yeah, that's a pretty fast growing though.
Yeah, it was like it was there. It
This
was
is
there, and then it
literally
wasn't.
24 hours
Yeah.
of video, and it was not there at all.
hmm
So this is the fun part of this kind of
Let's just
part
quicken
of the
this up.
cycle.
Let's do the continuum. You can see that even the magnetic structure of it wasn't there.
Yeah.
We didn't have any of the positive or negative polarities that then made the sunspot group show up. Yep, there it is. Cool. Well, I guess we'll see what the sun has in store for us there. It has quite a bit of developing to do still, so.
Just funny.
Looks like we really don't have. Let's pan again. Anything else though? And honestly, this is pretty small, so it's nothing to be concerned of yet.
Yeah, yet. Give it another 24 hours.
Yet.
We'll see what it looks like tomorrow.
Exactly.
Yep.
But I think that's all we got for the
Yep.
day.
That's everything I got.
I didn't see any questions in the chat that we didn't address. So, but this was kind of more of an overview anyway. You know, because it's fun to talk about this stuff now that it's over. And bye. On to the next thing.
Until the next event.
Yeah. Until the next event. Yeah, it's not this weekend. It's next week for Andy, right?
Andy's.
Okay,
Yep.
so we'll have.
I am looking forward to that one.
Yeah, I know a lot of people are. So that'll be a fun one. So next week we'll come up with something to talk about. I'm sure we will. Maybe it'll be this region that showed up today. So.
Well, at least there will be a kernel hole too.
Yeah.
Small one,
So.
but it's coming.
Yeah. Hoping for clear skies. This is the challenging time of year for basically everywhere. It seems it just is cloudy a lot. I mean, it's the rainy season for California too. I'm flying into basically rain. I just bring it wherever I go apparently. But yeah.
Nice.
The desert? Oh, it's gonna rain.
Well, you didn't take it with you when you went chasing.
That's true.
That was nice.
I had a couple days off there, but Norway it was really difficult. Sweden it was very difficult. But yeah, it's just that time of year. It's November. It's That's all I gotta say. So with that, I guess I could let you guys have your night back. I'm just making sure there's no nothing else in here. Just chit chat. I like when people chit chat with each other in the chat. So thanks guys for being here. As always, I'm glad. Yeah, you know, most people got to see something out of this wonderful thing. And then we'll be back next week with something to talk about. So, you know,
Yay!
there's always something to talk about anyway.
Yep,
All
for
right.
sure.
With that, I will let you guys go, and we'll see you next week.